involves wireless networks, defense, maternal health care, and safety solutions. He has filled nearly 10 plus patents for the same. He has founded two technical startups, JioVio and JioVio, in urban infrastructure and healthcare sector respectively, with a vision to build technology-enabled, self-sustaining communities in the society. He believed that we can achieve this only by bridging the digital divide in the society and by empowering the powerless, vulnerable. To this end, he actively engaged in community empowerment and education initiatives, especially among girls and young women, through Need to Mentor, a non-profit organization that mentors young women to innovate through technology. Currently, this community development initiative has evolved into one of the largest physical meetup communities in Tamilnadu. He has offered guest lectures in more than 80 higher education institutions in India and have been honored as top 5 technology explorers in India by NASCOM. He has won several hackathons at the national and international level. He represented India in Battlemesh research program in Europe. At present, he is exploring open source ecosystem and actively engaging with it as one of its contributors. Actually, we are privileged to have Shri.M.Senthil Kumar sir, who is combating Indian society with all on par with all developed countries with his technical excellence. Welcome you, sir. Thank you, sir, for your presence here.
Yeah, thank you so much, ma'am, for this opportunity. I'm just sharing the screen.
Yes.
Ma'am, can you provide me the
Yeah, yes, sir. I just make you as a presenter.
Yeah.
Yeah, you can now share your screen, sir.
Yeah, okay.
Yeah, yes, sir. Your screen is
visible. Okay. So, good morning, everyone, and thank you so much for this opportunity to deliver the session on application of cloud storage in IoT. Myself, Senthil Kumar, I am a founder of a company called JioVio Healthcare. It's a medtech startup company. We build IoT solutions specially designed for a pregnant mother in remote tribal villages. With our innovative IoT product, we could able to monitor pregnant mothers' vitals and their health status in a remote villages, and the data collected through the wearable sensors will be sent to the doctor for further screening and feedback. We almost provided 22,000 plus checkups for this mother, mostly living in a Western Ghat region. So to like now I'm going to explain about what is IoT. So this is the agenda for today's talk. It's more about like what is this basis of IoT and what is the cloud thing, because there's a new two different terms, and then various use cases of IoT, and what are the storage platforms available in the cloud aspect, different storage part. And I will explain some interesting use case to understand why we need a cloud storage. Especially for the IoT based thing. So even though I will come up with a very simple use cases and some of our patented technology, I'm explaining how we patented those technologies and what are the different use cases we are solving with the patent from our company. So if you talk about IoT, it's the Internet of Things. So first of all, I'll explain if we people are connected to internet, that is called Internet of People, where two people using internet to communicate each other. So from 1990s, internet begins up to 2006, 2010. There is only Internet of People, IOP, we can say, where all the people use internet to share, exchange knowledge, do communication between us. So that is called Internet of People. Now, researchers thought about, can we make machines to communicate each other? Okay, so can we make a machines, it can communicate to other machine and take better decision itself, not depending on human intervention. So that's why they started connecting these things. Things can be a sensors. These things can be a refrigerator. These things can be a light bulb. So they started connecting all the things through internet. They both start communicating to each other for better decision making. So that is, we call it as Internet of Things, where the things are communicating, things or objects are communicating using internet. So this domain was in started mostly 2005 2006, where all the industry use cases, consumer electronics, when the mobile phone, 2006-10 smartphone penetrated very aggressively into the market. So that is where we started believing that we can add so many complicated algorithm in a small sensor, small component. Before that, always if you take a hardware, the hardware is very big. But when smartphone come into the picture, we could able to run more instruction, billions of instruction in a very portable device, because all this internet connection need a powerful computer or powerful system. That day, our laptop or desktop has the powerful capability to connect to the internet and send data. But small sensor, small 8051 or small microcontroller, it don't have that capability to run an IP stack, connect to the internet. But later 2005, where the mobile innovation happened, we have a lot of portable hardware. Company like Qualcomm, company like Intel, they're all come up with a very portable and very powerful hardware that enables this new division called Internet of Things. We started believing we can run a powerful internet protocol in a small device and chipset. So this is a general architecture of any IoT application. There are set of sensors. There is a gateway, and there's a cloud platform, and there's a consumer application. It's a mobile application. So let us assume one simple example. In your home, you have a CCTV camera, or in your college or any place, you have a CCTV camera. Okay, so the camera is monitoring. Okay, this camera is nothing but a sensor. So you place the CCTV camera here. This camera need to connect to your Wi-Fi router so that this camera can access the internet. So the gateway is nothing but your Wi-Fi router, where you are connecting your sensor, nothing but a camera, to this Wi-Fi router. Using that, it starts streaming the video. Whatever recorded video, it starts streaming that video into the cloud server. Okay, where in some other place, example, in your home, you deployed one small camera. It's a Wi-Fi based camera. You have a router in your home. You connected your camera to the router, and through your internet, this data will be sent to the cloud server, where you have a mobile application, and you are not in your home, you are in your college or you are outside. Now you want to see what's happening in your home, if it's coming inside the home. So this is the IoT architecture. In IoT architecture, you have a sensor, you have a gateway, and you have a cloud server, and there is a consumer application to monitor and visualize what the sensor data. In our case, the videos are a sensor data. Okay. In early day CCTV camera, that is not IoT device. I will differentiate what is the CCTV camera and your home-based IoT camera. In a CCTV camera, the basic architecture is you have a camera. The camera is connected to the DVR, DVR or NVR. It's a digital video recorder, DVR. So there is a hard disk attached to the DVR. Whatever camera feeds the streams are collected, that will be stored in the DVR. Then you have a display attached to the control room, CCTV room, where it is all physically connected through wires. So some person sitting on the CCTV room inside your organization, he is monitoring what happening in the camera. Now, it is not connected anywhere to the internet. It is all connected locally. That's why CCTV means closed circuit TV. It is nothing but a closed circuit TV. Okay, our normal TV, what we see in a home, that is not a closed circuit, because the TV data is coming from satellite or through our cable network provider. But in a CCTV camera, you have a video provider, CCTV cameras. that is producing the video output that is closely connected to your TV. That is why it's called closed circuit TV, CCTV camera full form. It's not IoT device because if I am out of my college campus, I could not able to see what happening in the campus. I need to physically go to the college campus control room. I can open the desktop. I can see this CCTV footage. If anything happened in my college, I can only do post analysis. Post analysis means once that is happened, everything is recorded. Then people will come and open the video and they do playback. They do something called playback to identify at what time what happened. Okay, so this is a non-IoT devices. It's not connected to internet. It is not real time. It's always happen post. That means once every recording has happened, then we can come and do a playback. But in latest very small portable 3,000 rupees IoT camera, we can deploy the camera in our home, but we can monitor our home anywhere in the world. That is possible because this small camera could able to run powerful IP stack. That is like HTTPS, HTTP, entire Linux stack. It could able to run. So this camera now directly sends this data to the cloud. From the cloud, we can able to access this video footage anywhere in a real time. That is the main advantages of IoT network. So I explained with the camera, you can replace camera with your temperature sensor or pressure sensor, humidity sensor, where all the sensor data will be connected to the gateway, nothing but your Wi-Fi router. And from there, this data will be sent to the cloud. And this cloud data will be sent to our mobile phone. So in a mobile phone, we can see what is the temperature in our room. So if I need AC or not, before I go to my home, if my room temperature is 35 degrees Celsius, so what I can do, I can turn on the AC. So I reduce my room temperature to 25 degrees Celsius before I even reach my home. So traditional flow, how we will control AC, we will go to the home and we find a lot of humidity inside the room and we turn on the AC, put it on 25 degree, wait for minimum half an hour so that the room temperature will reduce from 35 degree to 25 degree. But with the IoT solution, before I even reach from my college to my home, I can open the app, find what is my current room temperature, which is like 35 degree. I can instruct my AC, hey, turn on and put your temperature as 25 degree. So half an hour travel from college to home. When I reach my home, my AC is already turned on and kept my room temperature as 25 degree. Okay, so this is one of the use cases or application of IoT and IoT based solution. Next, we talk about the cloud. We all know these are the cloud provider, especially having a solution for IoT. Because cloud is not limited to IoT, even though we can run web-based solution or computing, personal computing or cloud computing, lot of computing solution and server-side implementation. Everything we can do from the cloud. But today, our focus is more on IoT-based cloud services. So who are the providers? Provide IoT-based cloud services. So one of the famous is Amazon. Amazon has something called Amazon IoT Core. There's a solution or services from Amazon Web Services dedicatedly designed for IoT-based services, as IoT-based solution. In Google also something called Cloud IoT Core. So Google Cloud has a IoT Core, which is a dedicated IoT solution for the cloud implementation. And other companies like Microsoft has Azure. Azure has a AWS Core IoT engine for Azure's implementation. And other companies like IBM Watson, they are also having IoT-based solution. Oracle, Cisco, and IoT for beginners. There is a very basic level services will be offered in this cloud platform. And SAP is another company which provide industry-specific IoT platforms. A lot of industry-specific sensor, Industry 4.0 specific IoT platform. And ThinkWorks is another company, cloud provider, specially designed for DIY, basically do-it-yourself kind of IoT platform where any beginner They can build their own IoT solution and use ThinkSword's platform to send and receive the sensor data. So these are the way, and Bosch is mostly focusing on automation, car, and industries. SAP Bosch as a dedicated IoT platform for Industry 4.0 application, more on automobiles and manufacturing industries. So all these IoT sensor deployed in automobile and manufacturing industry can use Bosch IoT or SAP based IoT solution, specially designed for this particular purpose. These are the common cloud provider having a solution, because we have so many cloud providers, but these are the cloud providers having dedicated IoT solution. Their architecture is specially designed for IoT based use cases. So now I will explain one use cases. I will go deeply and I'll make you understand why we need cloud storage. Why we need cloud storage. So let us assume I am the consumer. In my home, I want to deploy one small web camera. It is basically an IoT based camera. So I bought it online. So now I deployed this camera out of my home entrance. Okay. Now what I have done, like I bought this camera, I just deployed the camera just in the entrance, so I can understand how many people are coming, at what time they are coming. So all the capture I can able to do with this camera. Now I have a Wi-Fi router. This Wi-Fi router is placed inside my home, and it is connected to the broadband internet service. It's connected to the broadband. Now I have mobile application to configure everything. So I'll tell my Wi-Fi router, hey, there is a CCTV camera and this is the camera detail. So I ask the camera to connect to my Wi-Fi router using its SSID and password, and then I will approve that it can access the internet. Then it will ask me basic services like, do you want a cloud storage? All those option is available. But what I am doing is I don't have initially at step number 1, I don't have any cloud services. I have a camera. I connected the camera to my Wi-Fi router. From there, this camera is streaming to the cloud platform, and I have a nice mobile app. Wherever I want to see my home, I can watch the footage in the camera. It's all real time. It's happening. Now it's not recording. It's just showing my video footage, but no video footage is recorded. So the camera company, they provided me option. There is a SD card. Okay. So I have SD card. So I put a 64 GB SD card inside the camera. So they provisioning a SD card where I can record all this footage, all this video streaming. I can record locally in the SD card. Now what I have done, I have a camera, I have a Wi-Fi router, I have a mobile app to configure everything to record the data. Now I connected a small SD card inside the camera. So this is 64 GB camera, and my recording is happening for 24 hours. Like 24 hours continuously recording is happening. So after like in a week, like a 1 or 2 week, maximum 1 or 2 week, my SD card got filled. Like all the 64 memory is filled. Now my camera is not able to record. So it's only streaming the video. I can see the live video, but no recorded footage. So now what I have to do, I need to again format the SD card, or I need to manually copy all the SD card video into my computer. Let us assume I copied all the 64 GB SD card videos into my computer and then formatted the SD card again. I have done everything manually. So formatted the SD card, again placed the SD card inside my camera. So again it start recording for next 1 week. So now I have so much 64 GB of video in my computer. You can assume my computer. My computer has almost 250 GB storage hard disk. It has 250 GB hard disk. I have in my computer. So first week 64 GB I copied. Now 64 GB is gone from my computer. Again second week all the data are captured. Then I got a notification saying that the memory card is full. I need to take the memory card, again copy the entire content, another 64 GB. So in a month, exactly 1 month interval, my SD card is over, my computer also got over because I have almost 250 GB of recorded video. Okay, because I'm storing everything locally in the SD card thing. So I'm manually copying that into the hard disk. So my problem now is like in a 1 month interval, all my datas are over, like all my storage are over. So now I come up with a solution, like alternative solution. I go through all this video, like what and all recorded. I'm going through the video. In the video, I find it. It is keep on recording the content. If people are coming, if people are not coming to my home, it's simply recording in front of the wall. There's a wall in front of the camera where if the people comes, it's still captured. So most of the time, I find it in my video footage. There's a wall. Okay, very few times there is a people are coming, opening the door, some people are going out. It's happening 24 hours if you take. There's a few time only this instance is happening. Like people are coming, people are going. But most of the time in my video, I only see a wall. Now I'm realizing that why I need to record the empty wall. Okay, it does not solve any problem. So why I need to record an empty wall? So now what I am doing is I'm doing some solution for this. Solution number one. Okay, I have enabled instead of a SD card storage, my camera provide a cloud storage functionality. Okay, so what I have done is I'm buying a cloud storage from Amazon AWS. It's called S3. S3 is the cloud storage services. So what I have done is my camera is recording the video. Now I'm not storing the video in the SD card. Rather, I upload the recorded video to the cloud storage provider. So the first month I exhausted 250 GB of my own computer hard disk. Now I thought, okay, this is too much, so I can't save it in my local computer. So I bought a S3 service. I can assume 1 TB cloud service storage I bought from S3. Okay, Amazon. So 1 TB, I bought it for some 5,000 rupees. 1 TB storage in a cloud, I bought it. Now, whatever data is coming, I directly redirected to the Amazon S3. So 256 GB data, it takes another 4 months. My S3 also got over because 1 TB of data is stored on my S3. Now, again, I go through all this video footage. I find one thing common. It's keep on recording that empty wall where people are not coming, people are not going. So the instant people are coming, people are going is very minimal. But 24 hours, it keep on recording that empty wall. Now, my data is in cloud in S3. Now, I'm adding one services, okay, one algorithm or services. So the services, what the services will do is, this services I'm adding in my own customized router. So I have built a small router. I replaced my TP-Link or home-based router with our own hardware, which is called GeoMesh. So this is a hardware I built myself. That hardware is deployed in my home, in the home itself. Now this hardware acting as my gateway. So whatever data is recorded, that data will be sent to my local Wi-Fi device, my local gateway device. So here I have written some simple algorithm. So in the algorithm, if the video has any human or motion, if any motion is there in the video, priority number one. If that motion is the human, then I will record or I will store only the footage where the human is coming in front of the camera. So only that footage I will store and upload to S3. And all other empty wall, I'm not going to store. I'm deleting all that content. So there's a small algorithm running on the gateway. What it's doing is it's capturing the real-time video footage and finding is there is any human. So I use AI machine learning just to identify the face of the human. It's a kind of a face identification. I put a small rectangle in the picture and I recognize if there is any human faces there. If a human face is there, until the human face present in the video, I record and store the video, and all other remaining video I started discarding. Okay. Now after doing this implementation, I find it every day approximately it sends 1 GB of data. 1 GB of recorded video, it uploaded to the cloud. But after doing the small implementation, I find it spent only 56 MB of recorded video. Because the human intervention is someone is going out or come inside. It's a very rare few events happening in the whole day. So my intelligent device now only captures that interval, 30-second or 40-second till the human present in the video footage. It captures that interval and it upload into the cloud server. Now my cloud server upload is reduced from 1 GB per day to less than 56 MB. Okay. Now again, like you can say, I can extend my capability because it's continuously working every day. 56 MB is doing. Now I started analyzing again in the cloud because everything is coming into the cloud. The advantage of being cloud is I can write a lot of algorithm. I can use machine learning model. Whatever I want, I can use it in the cloud. Still optimize the service. Okay. Now I open all the video footage of 1 month and seeing that every footage has my parents, my sister or my uncles. These all people, well-known people. I see all their movement is captured. But I deployed the camera because I want to monitor if any unknown person, the person is not a family member, not my relatives. If there is an unknown person coming to my home, standing in front of my home, I want to record that particular event. So I come up with another model. Okay, can I build an algorithm where I can feed all my family members and my relatives photo into the algorithm? Okay, so what my algorithm will do is now it capture the image. Step number 1, identify human presence is there or not. If human presence is there, it will do two things. Do a face recognition with that particular video frames. If the face matched with our family members or relatives or friends, what I did is I simply uploaded my my basic contact information, contact profile, my family contact, my relative contacts with their photos. My model is trained with that photos. Now it's recognizing if there is any image picture is matching my family member or my relative, then it can discard that recording. So it can only record a set of people who are completely unknown, and that captured image only stored on this backend cloud storage. After doing this one, I realized that my upload size reduced from 56 TB to sometime 1 MB or 2 MB. It is reduced from 56 MB to 1 or 2 MB because in a day, very rarely 3 to 4 people visit my home. Some person from a postal service, someone like a gas cylinder. So very few instant this kind of a people are coming. So my algorithm is optimized very well. It only upload that new people who are coming to my home, which is not matching with my database. So after doing this small implementation, my storage size is reduced because now I just need to upload 2 or 3 MB video footage to the backend cloud services. So uploading the data in the cloud service allows me to do a lot of machine learning and AI stuff, and I could able to optimize the storage also. I could able to effectively optimize my storage, and then I could able to do better decision making with that cloud storage. If it is in my computer, let us assume if every data is stored on my SD card, I need to manually copy the data into my computer. So what I do physically do is copy the data into my computer and go through every video. If the video don't have any meaningful thing, I need to delete that video. It's a very painful task. As a consumer, every month my SD card will get over. So I need to copy entire data into my computer and go through, open the entire video flow and analyze what is the useful video, what is not that useful video. I need to delete all the video. But now pushing my data to the cloud platform, I could able to store only the meaningful necessary data, and I am seamlessly able to discard. And I have done a lot of optimization of the cloud storage, even the local storage also. That is where IoT plays a very vital role, because the biggest challenge in any IoT based solution is data storage. If we put a small temperature sensor and start capturing the temperature value, which is less than a KB, I can say like 100 KB data. but it is producing on every minute interval, or every 5 seconds, it's generating the temperature data. That means in 24 hours, you will get very huge temperature data set in your cloud. Okay, so you can't manage this huge amount of data set in a local hard disk or in a local server, local premise server. This is where the cloud come into the picture. In a cloud, the bigger advantage is I can get a meaning out of the data. See, I don't need to store every data point. I can find a meaning, like, no, what time it rised, what time it went down, what period of time. So my data will be, see, the data is pushed to the cloud, and there's intelligent extraction is happened. So you have a, like, 100 MB data, and our algorithm come to the picture, go through the 100 MB data, and it is produced the abstracted meaning of the data, and you can discard all the 100 MB data. So this is only possible with IoT based solution. So especially this cloud enabled storage. So I explain some of the storage platform. One is like S3. S3 is the very famous storage platform from Amazon, and Amazon has a various cloud services where it is continuously streams the data, analyze the data, and meaningful data it will store to the S3 storage. So, and Microsoft, they have something called Blob Storage. Blob Storage is dedicatedly designed storage service from Azure. And for the Google Cloud, they also has the, Google Drive is one of the storage unit, and they have other set of cloud storage. It's called Cloud Bucket. They call it as a Cloud Bucket. So using those services, we could be able to store and stream this data. So yeah, I'll show video use cases of this one. The better. Yeah. So this is what I explained about AWS IoT core. Just to play.
At AWS, start our customer engagements for IoT with one simple question. If you knew the state of everything and you could reason on top of that data, what problems would you solve? And we made it our mission to make sure that you can know the state of all your devices and that you can reason on top of the data so that you can truly solve your business problems. We help customers like Enel, a power company from Italy that uses AWS as its IoT platform for energy management. They are building AWS IoT and greengrass-enabled gateways for homes and the power generation sites, so they can process and act on large volumes of data within milliseconds. Symantec's award-winning router and security solution for homes utilizes AWS IoT in the backend. The mining company Rio Tinto utilizes AWS IoT and greengrass on their logs in the boron mine. They determine real-time heat maps of road roughness, which allows them to optimize wear and tear on this heavy equipment and saves millions of dollars. And Philips Healthcare runs its Health Suite digital platform using AWS IoT to help create better healthcare. And these are just a few examples of how AWS IoT is helping a lot of customers solve business problems. We help them by providing edge-based software, including Amazon FreeRTOS and AWS Greengrass, that allows our customers to securely connect their assets, gather data, and take intelligent actions locally, even when the internet connectivity is down. We help them with cloud-based services, including AWS IoT Core, IoT Device Management, and IoT Device Defender, that allows customers to quickly onboard their large and diverse fleets of devices, maintain fleet health, and keep their fleets secure. We help them reason on top of their IoT data with services like AWS IoT Analytics that allows our customers to easily analyze their IoT data. It also integrates seamlessly with Amazon QuickSight for visualization and Amazon SageMaker, our hosted machine learning service. And last but not least, all AWS IoT services are built serverless, means our customers take the full benefit of the elasticity of the AWS cloud to build their enterprise applications, and they don't have to worry about scalability or utilization. Truly own for what they need. So, what does this mean for you? It means that no matter what business you're into, AWS IoT can help you extract value from your connected devices. To understand this a bit better, let's take a deeper look at all the AWS IoT services one by one. Starting at the source, where most of the IoT data is generated, we provide Amazon.
So before now going through this video, I will give some context. What is all this the service he explained? So see, this is common for this is AWS one, but if you go to Google Cloud, almost the architecture is same. And if you go to Azure or IBM Watson or Bosch IoT suite, almost the architecture is same. So only the naming will be different based on the company. So if you go to this slide. See, this is their general architecture. They have a two thing. This is for the things I told, the hardware or sensor, which is attached. I can assume that the camera. So the camera can be powered by Amazon free RTOS. RTOS means real-time operating system. So initially I told our old 90s or 2000, whatever sensor microcontroller we have, that is not capable of running a operating system. That is it runs only a small instruction. Microchips runs a very small set of instruction. But later stage, whatever hardware we have, that has a capability to run a powerful RTOS, real-time operating system. So the operating system we are running on our camera or a smart light bulb or even the refrigerator controller or air conditioner controller, that operating system name called Amazon Free RTOS. And there is another service called AWS Greengrass. So in when I have explained, you see, I have a camera. This camera will capture the data and send it to my router, which is specially designed edge router. Edge router means the router itself can take certain decision. Can I need to upload this data or not? How it will do is, in this router, I am running something called AWS Greengrass. It's a edge service. What this edge service will do is, it capture the image and locally runs algorithm if there is any motion is detected, as if there is any human face in the video. So I'm filtering out my video in my gateway itself because it's continuously capturing. So what I'm analyzing is if this video footage has any human face. So there is a small algorithm which can be a AWS Greengrass. It's a edge solution, edge algorithm. This algorithm will run set of models. What it will do is, in my image or in my video footage, is there is any human face. Understand one thing, my algorithm is not capable of doing face recognition. It's only detecting is there is any human face or not. Because face recognition need more computing power. Because you need to compare with the existing face data. It's a very computational intelligence. But for human face, it's a very simple algorithm. It has to put a rectangle and there is a nose, there is an eye, there is a mouth. It's a very simple algorithm, edge algorithm I can run just to identify if there is any human face in the captured video. So this two solution which will be running on my things. Here you can see things mean sensor and some gateway. Okay, this two solution is running on my things, which is Amazon Free RTOS, it's operating system, and AWS Greengrass, which is nothing but a solution. It's edge solution where it can do some analytics, some kind of a processing of my incoming sensor data. Then the next one is called, if you go,
we help them with cloud-based services.
Yeah, this is all the cloud-based solution of Amazon. It is called AWS IoT Core. So before I go into that, now you find it a two solution, which is like Amazon Free RTOS and AWS Greengrass. You may ask the question, this is Amazon one. What about Google? What solution Google has? Google has something called Android of Things. It's called Android Things. It's a dedicated operating system. It's an Android, whatever running on our mobile phone, same Android, but stripped down into the smaller version for things. So they released something called Android Things, specially designed for small hardware, small sensors. Okay, and they have a Android things itself combined with the operating system, because it's Android OS, so it's very powerful to run set of algorithm. Android is combined these two different solution into one platform. It's called Android Things. Then next is a cloud-based solution. We have a 3 cloud-based solution. First one is called AWS IoT Core. So what it will do is, it will enable a MQTT-based protocol where our sensors can send the data stream. Our video camera can send the video stream to this IoT Core platform. It's a platform. What it will do is, it's just to collect the data, capture the data from our sensors to this IoT Core. The second solution is called AWS IoT Device Management. Example, I have a camera. I can put 10 camera in my home. So I need to manage all the camera. I need to say, okay, this is a camera number 1, and that is deployed on room number 1. This is a camera number 2 deployed on like in a parking area. This is a camera number 3 deployed on my like in my balcony. So I can configure all the devices in the backend. I can know the status of it. If the camera 1 is on or off. Okay, I can control everything. That is using this platform called IoT Device Management Platform. And next is AWS Device Defender. It's kind of a security thing, because I want to ensure that my device are safe and it's not hacked by some hacker, and the data captured is reliable. So I need some kind of a security layer. So that security layer will be done by this AWS IoT Device Defender. And the third is, if you go to the next slide, it is nothing but AWS IoT Analytics. Okay, in my example, I have a camera. The camera runs Amazon RTOS. Okay, and I have a router. The router runs Greengrass. Camera just capture the video and send it to my router. The router is running an algorithm. The algorithm detecting human face. Okay, once this is done, it's sending that recorded video to this AWS IoT Core. It's like a stream. Continuously the videos are sent here. And I have a device management where I can manage all my 10 camera in my home. And I have a security layer where I can ensure that my camera is not hacked and not someone is accessing my camera without my permission. And the data are safe. So I can manage everything here. And next thing I told that now the camera footage is coming. It has only a human faces. All the footage has a few human faces. Now I want to add some analytics or some machine learning algorithm. The role of the algorithm is go through these images and find if they are my family members, if they are my friends, if they are my relatives. If they are my family members or my relatives, discard those recordings. Only save a recording from different people, not my family member people, some unknown people come to my home. Only store that recording and store that video footage to the Amazon S3 storage. So this is a complete explanation of how I am using AWS services to provide a cloud storage, optimized cloud storage for my video camera, for my any IoT sensors. So here, so I just give the explanation so that he also explain about it in a different manner. And I will explain what does the serverless mean. It's a new term. Everywhere people are using serverless architecture. See, if it is a server-based architecture, it means that you have a dedicated computer sitting on your cloud where your Linux server is running, and all the data are manipulated by the Linux server. So if you run a video camera, or if see example, I have a camera and I put a dedicated Linux server in the cloud. If let us say I go outside or I'm inside my home, there's a power cut or I am not at all using my camera because it's faulty. Okay, I still pay my server cost. Example, my server cost is 1,000 rupees in a month, but my camera is not working because it has some repair, something. I'm doing some kind of a housework. So my camera is not working, but my server is continuously running. So I need to pay 1,000 rupees every month, irrespective of if I use my camera or not. In a serverless architecture, there is no dedicated server. Amazon will give their own optimized server Now my model is, if my camera is running, then only I need to pay the server charges. If I turned off my camera, I'm not using the camera, there is no server is running, because Amazon using its own optimized server. It's a demand-based server. If it is running, then it's turn on the server, run the server for me. If I turned off the server, Amazon itself optimized the servers to use it for a different purpose. So serverless architecture means I don't have a dedicated server and I don't need to pay without using the server. I don't need to pay money because I'm not using a camera, so I don't need to pay my server charges if I go with a serverless architecture. This is where everywhere people talk about serverless architecture, because it drastically reduces your pricing, your cloud pricing. If you take any cloud engineer, they prefer more on serverless architecture because they can optimize the cloud cost. If every month, if you spend like 10,000 rupees, they try to optimize how many services, on demand services, I can able to push the services into the serverless architecture. Now,
to understand this a bit better, let's take a deeper look at all the AWS IoT services. Starting at the source, where most of the IoT data is generated, we provide Amazon FreeRTOS, a free open source IoT connected operating system for microcontroller-based edge devices. It extends the market-leading FreeRTOS kernel with software libraries that make it easy to securely connect your small, low-power devices on a local network to more powerful devices running AWS Greengrass, or connect via the internet to AWS IoT Core in the cloud for analysis and action. It also keeps edge devices secure with security credentials and key management, and it keeps your data secure with password. We also provide firmware services for Amazon FreeRTOS with integrated code signing that keeps your devices up to date. For more powerful edge devices like gateways or programmable logic controllers running Linux, we provide a software runtime called AWS Greengrass. Greengrass extends AWS IoT functionality to the edge and installs on your local devices so that they can take local actions quickly at the edge. Using the serverless programming model, you can easily write and test Lambda functions in the cloud and deploy them onto a Greengrass core device, taking benefit from local resources and peripherals these devices offer. Your Greengrass-enabled devices continue to route local messages even when they lose internet connectivity. And when the connectivity is reestablished, they automatically sync data and device state securely with the AWS cloud. AWS Greengrass does this utilizing the very same security mechanisms used in the cloud with AWS IoT. And it's updatable, so you get access to new features and security enhancements.
so you can understand the two things. The microcontroller using RTOS, AWS RTOS, free RTOS. The gateway, the router using AWS Greengrass, because now this gateway can do a lot of local action. It's called Lambda function. It can go through the video and find if there is any human face. So it is a function, it's an algorithm. So it can run various local function and it route the message. And another important thing, if there is no internet, it still can collect all the video footage, store it inside, and when the internet come back, it can push or sync the data back to the cloud. So these are the different services this AWS Greengrass can do.
Along with Amazon FreeRTOS and AWS Greengrass, our cloud-based service, AWS IoT Core, forms the backbone for IoT deployments to securely connect all your devices and handle their data at scale. AWS IoT Core allows you to securely connect devices to the AWS cloud and with each other. It allows you to route, process, and act on the data and messages coming from those devices. And it also allows you to deploy and develop applications that can interact with your devices even when they're offline. Onboarding a few devices is easy. Doing so for millions and keeping your distributed device fleets healthy is much more. That's why we provide AWS IoT device management. It helps you onboard new device types and provision them in bulk. It maintains a catalog of device information and configuration, like serial numbers and policies. It also indexes dynamic state information, such as temperature or RPM. You can then query devices based on both static attributes, firmware versions, as well as dynamic state, such as temperature in quasi real time. AWS IoT device management monitors your devices to diagnose and troubleshoot issues, and then allows you to remotely perform over-the-air updates to your entire fleet, subfleet, or individual devices. Security has always been our #1 concern at AWS. With AWS IoT Core, you have already built-in device authentication and authorization to keep your IoT solutions safe. However, with all the new device types being deployed across so many different environments and locations, it's hard to always know if your security policies are implemented consistently across your entire fleet of devices. That's why we are building AWS IoT Device Defender to continuously audit the policies associated with your devices. It also monitors your device fleet for abnormal behavior that might indicate a potential security issue. And it alerts you if something doesn't look right, like traffic from devices to an unauthorized IP address, or spikes in outbound traffic that might indicate that the device is participating in a DDoS attack. And finally, through its integration with IoT device management, IoT Device Defender lets you take corrective actions to keep your devices secure. Now that you can maintain your fleet health and keep...
Yeah. So now we see the cloud aspect of it. There are 3 components in the cloud. First one is IoT Core, AWS IoT Core. That is a backbone of all our connected devices, sensors. It uses to send the data to the cloud. It's a main first interface to receive all the data, sensor information, video footages. Second, we have AWS device management, because one device, it's easy to manage, go through the data set. But if you have 100,000 device, then it's very difficult to maintain all the device, and maintaining if the device has any lag or some device, the data is not coming. So maintaining all the device is very painful. That's why we have AWS IoT cloud management, a device management, where we can monitor all the device performance, and if there is any devices and online, offline, the status information, everything we could able to do it from AWS device management. The third is like I told about security, because now you have millions of devices. Any one of the device, the hacker can attack and start injecting a malware into your backend. And from that backend, the malware can be updated to across the device. That is possible. So to monitor the security and behavior of all our 1 lakh devices, we need some algorithms. That's why we are using AWS Defender, IoT Defender. So the Defender role is observing all your 1 lakh devices and find out is there is any abnormal behavior, is there is any data abnormally coming from the device or not. So you can continuously monitor and provide the security solution. So we have 2 framework for the device side. Device side, we have 2 framework, and then there's a 3 framework services in the cloud side. And another one is analytics. I will explain the analytics also.
Secure. The key question is, how do you generate value from the device data? That's where AWS IoT Analytics comes in. It is a fully managed analytics service to easily analyze IoT data. It can run analytics on massive volumes of IoT data without having to worry about all the cost and complexity typically required to build your own IoT analytics. It filters, transforms, and enriches IoT data before storing it in an IoT-optimized data store. That way, you can easily query your data using the built-in SQL query engine and visualize your outcome using Amazon QuickSight. AWS IoT Analytics also supports more sophisticated analytics by preparing your data for machine learning using pre-built Jupyter Notebook templates of machine learning models that can be trained and run using FDP. And to close the loop, you can deploy your cloud-trained machine learning models to an edge device with AWS Greenhouse. That means you can make predictions based on locally generated data without a round trip to the cloud. Application developers can now add machine learning to the devices without having specialized machine learning skills. Finally, we thought about whether there was a way to make it even easier to get started. Maybe you just want to be able to press a button to get the hotel staff to pick up your dirty dishes from your hotel. Or on the factory floor, you just want to have a simple button next to your machinery that calls a service team member to fix the machine if something doesn't work. What if you just needed to acquire a device, configure it in a simpler way to execute a dedicated action, and it just works? This is how we came up with AWS IoT one-click, to enable one-click creation of a trigger for AWS Lambda function for pre-configured simple devices like a sensor. With AWS IoT one-click, you can select and order devices that ship fully provisioned to securely connect to AWS IoT. You can configure and deploy those devices with just one click via a simple mobile app to take dedicated actions. And you can easily define attributes and extract reports on your devices from the very same mobile app. With the help of AWS IoT, you can know.
Yeah. So in analytics side, like now here I explained about something called SageMaker. SageMaker is AWS own machine learning platform. Using SageMaker, we can able to deploy a lot of ML models, different ML model. One of the ML model in our previous use case I explained, face recognition model. So in the face recognition model, I feed set of photos, and my model has to identify if the photos are matching with the videos. If it is matching, discard all those videos, because I know all the people, so I don't need to analyze those videos. I only need to store unknown people footages. So the SageMaker can help me to do all this machine learning stuff. So this is the overall architecture. It's one example of AWS IoT services, but this is almost the same if you go with any provider. If you go with Google, if you go with Azure, almost this architecture is same. Here we know that the hardware side, two part we have. One is like Amazon FreeRTOS, Amazon Greengrass, and AWS side we have IoT Core, which is the cloud aspect of it, and for device management and device security, and to do a lot of analytics and reporting to visualize the data, like how many time unknown person come to my home. If I want to see that visualization, that and all possible with this analytics tool. And another services, Amazon is, it is a kind of a do-it-yourself or easy to learn kind of a services, which is called AWS IoT one-click. It's Amazon itself will give a device. Amazon give their backend services, cloud, everything configured with a simple mobile app. So we can deploy. So one use cases he told, let us assume like one simple use cases where Amazon itself using this one-click is they deploy this Amazon one-click button in a refrigerator. In our home, every refrigerator, they deploy that that Amazon one-click. Example, if you have a tray for the milk tray, so they deploy that switch in the milk tray. If you utilized your milk, okay, now you need to order another milk. You just need to press the button. Okay, see example, you want to make a tea, like you have taken the milk already from the dryer. Now you just need to press the button. What it will do is it directly call Amazon e-commerce services, and it order the milk packet, and the milk packet will automatically refilled in your refrigerator. So this is one simple use case of this one-click solution. Another use case he explained, like every machineries in a industry have this button. If the machinery is not working or any service needed, the person who is handling the machine just need to click that button. It automatically raises the service support to the backend team, and backend engineer can come back and fix that issue. So these are the another use cases of AWS and IoT services. And if I replace the entire architecture with the Google, here I go with something called Android Things. It's a one single platform combining with the operating system and then software services. And here I have a cloud IoT core, and I have a same Google IoT device management. And here I have like a Google security services. And here all Google App Engine or Google Cloud Engine, where it can do all the analytics on services for me. So this is the same architecture replacing with the Google services. I hope this gives some context about IoT and why we need a storage, why we need to push all the IoT data into the cloud. I explained because IoT is going to generate huge amount of data, and we can't store all the data into the local storage SD card. That is not possible, and you can't store it in a DVR also. You need a cloud storage because you are going to get a millions of streamlined data. So, and you need a lot of services so that you can optimize the storage. So we discussed about various services and various IoT architecture, how we can optimize the storage and how we can enable this seamless functionality between the device, software, and user reporting. How the entire architecture can be seamlessly connected. And we saw one particular industry use case of a button, how the button works, how it can trigger particular services and enable that services seamlessly delivered to the customer. And in the video itself, they have demonstrated various solution in a solar company, how the solar company managing all the solar panel using IoT devices. So the IoT devices know that what is the current is produced by the solar panel. And when the solar panel, see, the biggest challenge in solar panel is the solar panel should be clean. The panel should be clean so that it can effectively generate electricity. Okay, so one of the IoT use cases, you're attaching a device, a small sensor, continuously monitoring the current produced in the panel. If the amount of current produced in the panel is start decreasing, that means this particular sensor can alert, hey, it looked like there's a dust on the solar panel. That's why its current production capabilities reduced. So we need someone to clean. So in a backend analytics, it can tell from this particular area, this set of 16 solar panel need a cleaning. So this is all possible with this kind of architecture. We can seamlessly manage more than 10,000 solar panel sitting in one cloud backend provider. So this is the industry-wise use cases for this application. And I hope you got some basic understanding of IoT storage and various service provider and what is their architecture and how industries are using that architecture to build some end user solutions. Yeah, so if you have any question, you can feel free to ask me. And yeah, thank you so much.
Participants, if you have any queries, you can ask now.
Good afternoon, sir. Yeah, sir, your session was really good, sir. Able to gather more informative things about that. I have one small doubt, sir.
Yeah.
You said about AWS, sir. Which is the best platform for storage, sir?
See, for the storage, I told now there are three providers. One is AWS, Google, and Azure. Okay, so if you see cost wise, AWS is cheaper because AWS is started very early and they have a huge deployment. So cost wise, AWS will be cheaper. But if you see most of the enterprise use cases, Azure will be better. Azure storage is better than Google or AWS.
Okay, sir. Based on security, which is the best one, sir?
Based on
security.
If you talk about security, Google has the best security framework. Okay, and because they manage massive cloud services, so their storage security is really better than Microsoft and Amazon. So you can see this category. Cheapest one is Amazon. Enterprise grade is Azure, and more secure one is Google.
Sir, I also have another doubt. Is there any surety that our data will not be given at the back door of any other storage on cloud?
What is the question, sir?
Sir, it is my doubt that we are storing our data. Okay, either it will be given to any other some other persons
No, that is not possible. Because there is a security rule where your data will only visible to your account only. It's not even shared. And
Okay,
policies are there where it is not like you store the data and this data can be shared with any cloud provider. That's not possible.
Okay, sir. Thanks a lot.
Yeah.
Good afternoon, Senthil sir. This is Dhanam.
Yes, ma'am.
Yes, sir. Thank you, sir. Your session was very, very, very informative and it is very useful. And you have clearly explained about the IoT fundamentals and applications and what are the services based on IoT. So it was clearly you have delivered. So it will be useful for many of us. Thank you so much. Your
Thank
session
you, ma'am.
was really, it was very interesting and informative. Thank you so much, sir.
Thank you so much, ma'am. Thanks for this opportunity.
Yeah, thank you, sir.
Participants, any other queries from your side? Senthil Kumar, sir.
Yeah, yes.
Yeah, it's actually many were saying even in some business magazines and everything, we are hearing that we are in the near future towards robotics and some IoT and all. So how far it will be helpful in the healthcare applications, sir? Because nowadays we are dealing with many new diseases day by day. These diseases are updating on par with technology. We can say right now.
Yeah.
Yeah, actually economy and everything is facing some crisis over this. So how can we mitigate this using this technical advancements?
Yeah. So basically, one thing I want to tell, if you take any vaccine in our history, if you want to make any vaccine, on an average, it will take 2 to 3 years to design a vaccine. But this is in the first time in the history we made a vaccine in a 6-month time frame. This is possible because we have generated various machine learning model and we simulated different DNA RNA combination. So this is only possible because of the technology and the machine learning model what we have built. Because all this bigger company right now they are using a AI based solution to simulate real human cells, okay, and they apply the vaccine and find various cell behavior after applying the vaccine. This all simulated in an algorithm. So this is possible because we have a very powerful computing. Yeah, so we have a very powerful computing platform, and that enable this faster deployment. Another IoT kind of a solution I want to tell even to our use cases. See, we have in our company we made one device which is called Allo Tricoder. During this COVID time, we closely work with the Tamilnadu government, where most of the patients who are COVID positive, but they didn't get a bed admission in the hospital. Okay, because there's no bed available in the hospital. So with our technology, what we have done is the patient will be sent to their home in a quarantine mode, and we attached our wearable device on the patient. In a real time, we collected all their vital information, blood pressure, heart rate, saturation in a real time, and seamlessly we transmitted the data to the doctor portal. So throughout the 14 days quarantine, the patient is in the home, but the doctor could be able to monitor her vitals, respiratory breathing cycle, and how much oxygen he has in the blood, everything through using the IoT device. So this kind of a technology really enable faster vaccination and provide a personalized home care. That's possible with IoT and AI solution.
Good afternoon, sir.
Yeah, good afternoon.
This is Balaji from Global Institute of Technology. So my question is, So when we share our healthcare information through IoT devices, so what kind of security and personal information can be shared like this? Because is it possible to other person to have this or get this information for their own purpose? Now, and recently in Kerala government, they transferred all medical information to the American-based company. The issue was raised by the government of Kerala. So it is not safe to send this kind of healthcare information of persons to other countries because you are storing data in a cloud environment in remote location. We don't know who is handling this, who is managing this, or who is able to edit this, or some modification can be done this, or it can be used for malfunction. So what kind of security we can provide this kind of health information? Is it safe for transferring a personal information, health information to a cloud environment?
Yeah, so that's why, sir, like, we have various device specific algorithms. So in our case, I'll explain how we are doing that thing. See, when we attach a device to a particular patient, we capture his fingerprint sample. Okay, every data is collected from that particular patient is encrypted with his fingerprint sample. Okay, so this data is encrypted. So in the backend system, okay, the backend system, it's all encrypted data stored in the database. If someone is opening the database, someone is trying to see the data, it's all encrypted hexadecimal numbers. Okay, so how the data can be decrypted is if a doctor, very authorized doctor, he's open up the patient name, he's clicked the patient name. Now the portal will tell us this data are encrypted. Now I need to click one button called request. When I press this request button, there is one SMS will be sent to this patient detail, the patient phone. Okay, where there's a two form of authentication we right now provide. The link will be sent to the patient phone. The patient need to click the link, and then it will open in the mobile phone. It asks them to put the fingerprint in their phone. If the phone has a fingerprint sensor, it will ask them to do the fingerprint in the phone. And again, the data will be decrypted. So the patient know that, yes, this particular doctor accessing my information, and I'm acknowledging that, yeah, he is the right to access that. So this is one layer where the particular patient information is protected. The second layer is most of these companies, big companies, because see why this American company need data, I'll tell. Because they want to build a machine learning model. So the machine learning model need huge amount of data so that it can take better decision. The biggest mistake is in our government, the biggest mistake is they don't worry about the importance of it. So what they will do is they will give the entire data set dump to the customer. Instead of that, if the data is scrambled and then the personal data will be removed. See, if you take any data, it has a two component. One is a personal information and their medical information. See, people worry about this personal information because if I know personal information, I can relate this medical information is belong to this particular person. But most of this algorithm specific thing, what people do is they discard the personal information and there's just a basic medical data. We can't even relate to which person belongs to this medical data. Now the basic medical data is populated and it is scrambled. The data is mixed with multiple things. Then that encrypted data feed it to the machine learning for a learning purpose. This is how we can protect the personal end users data. No one can remap it. See, I have a data set which is medical data, but I really don't know whose medical data it is. Okay, so this kind of a production we need to do. It's a user responsibility, and of course the person who built the solution, their responsibility.
Thank you. Very useful information and very useful session, sir. Thank you.
Thank you. Thanks, sir.
Sir, I want to ask you one more question.
Yeah.
For encrypting your information, what algorithm you are?
So we are using something called SHA-256. SHA-256 is an algorithm we use to encrypt the data. And there are another algorithm like RC algorithm, AES algorithm. So there are various algorithms that are available, but we use SHA-256 to encrypt the data. So the key is fingerprint is the key. For our algorithm, always algorithm need a key. It is called private key. So the key will be given and there is a corresponding public key will be generated. So from the doctor's side. So the doctor need to request the user, hey, I need to see your data. Then the public key will be enabled in the doctor's side. Private key kept with the patient. This is a model we use.
But there are so many algorithms, as you said, sir. Why specifically you are choosing short 256?
Basically, this algorithm, this
Everything is
select.
secured algorithm only. Among these algorithm, that is my question is why you have chosen this short
Okay.
256?
See, this algorithm will be chosen based on what data you want to encrypt.
Okay.
Okay.
What type
See,
of data?
what type of data? See, if I want to encrypt a image data, there is a picture. I want to encrypt the picture, then I will use a different. I use a ACS algorithm.
Okay.
Okay, AES algorithm to AES mean advanced encryption systems in a set of algorithm. So any image based one, I use this AES to encrypt and decrypt. If it is a data driven, I use SHA-256 kind of algorithm. I use for data driven data set. It
Okay, sir.
completely depends on your data.
Okay. So actually, for FPGA devices, they will provide one key. That is, that keys are provided by means of some circuit called puff circuit. I think you would have heard that term. In that, there are so many types of puff circuit. Which one is best suitable puff circuit? I mean, that circuit is to be implemented with some security algorithm. Is it possible to implement this RSA, I mean, short 256 algorithm in puff circuits for identifying this FPGA devices? So,
Okay.
actually, the purpose is to identify, to make a unique key, to generate a unique key for each FPGA devices. My question is it possible to implement this short 256 algorithm in this pub circuit for generating this key
Oh,
for security
what
purpose?
is the data you are feeding
So
for this?
normally to identify an IC, I mean there are so many ICs are manufactured in a, manufacturing side, that is in a foundry. They will produce bulk ICs. In that, there are chances of manufacturing some fake ICs also. So to identify that particular IC, we go for puff circuit. So for generating the key only, the purpose is to generate a secret key to identify that original IC. So
Yes.
I mean, that is what I want to get that algorithm only, about algorithm. There are so many algorithms you said. Among these short 256, I mean you said depending upon your application. If
Yeah.
this is also data driven, I think. So it is possible. Is it possible short 256 to implement in puff circuit for identifying FPGA devices?
Okay. See, currently I will explain like how our IMI number. If you buy
Okay.
a mobile phone, every mobile phone come up with the IMI number.
Okay.
Okay. Since this IMI numbers are generated is nothing but a security key. So that we could able to track that IMI number and find, because we are not allowing two IMI number for the same phone. Like IMI number should be unique. So people are using specific algorithm only for that, even though it's not even SHA-256, it's not even ACS. There are a specific algorithm. It's a tool. The tool will be used to generate the IMI number. And the interesting thing is this tool is globally accessible. Like example, if a foundry want to manufacture a mobile phone, this foundry will register for the IMA number system. So every device they manufacture, the IMA number will be generated specific to the particular manufacturer. If another manufacturer want to generate the same number, the system ensure that the number is not repeated. Okay, so they're not using STAR 256, they're using a specific platform. I just need to check what algorithm they are using, but all the foundries, all the chip manufacturer, they are using a common platform. For all the manufacturer in the world, they have to use that common platform to for that number, that secret number. They call it a secret number because that number is used to identify what chip went inside. So that will be connected to their bill of materials. This is a particular chip ID is attached with that.
Sir, can you explain?
Uh,
Hello, sir. Senthil, sir. Good afternoon.
Recently, I have heard from Rajesh. You have developed an app. great have something. So can you explain about something?
Hello, Senthil sir, I have a question. Senthil sir, can you hear me?
Yes, I'm able to hear you.
Sir, actually, for example, it is a live example. Okay, a few days before, one of my known friend, he got suicide. Okay, he suicide. Okay, so
Yeah.
unfortunately, my friend, what he has done? Okay, the guy who has suicided. So somebody has teased him. Okay.
Mm-hmm.
Okay, then that was not intention. Okay, that was not the reason. Okay, and my friend sent to that fellow. Okay, my friend to the guy who suicided. Okay, he sent a message. Okay, why are you so sad for a few days? And he just sent a message in WhatsApp.
Okay.
Okay, so now my question is, okay, if the police, because when he sent a message in WhatsApp, okay, he was not seen that message. It was only in single tick. Okay, even that was not delivered to that fellow who suicided. Okay, so now my question is, if police is about to go with the investigation, so will it affect to my friend? That means since he did not receive any, that fellow did not receive any message, the guy who suicided, and in such case, how police are going to deal?
Actually, see, 100%, 100% they will talk to your friend.
Okay.
Just to understand the context.
No, there was no intention. Okay, there is no relation. Like there is no simply as a common message. Okay, why you were sad for 2 days before? Okay, in the colleagues who made you as like a fun. Okay, it was only common. Okay, don't worry about that. Okay, take it as a casual. But the reason for suicide is something else.
Yes. No, but that's why they don't enter action. But they, for the general purpose, they will inquiry them.
No, but since my friend, when he sent the message in WhatsApp, but that fellow did not receive the message. Okay, the mobile was not in the range. That means like even that was not in double tick also. That means that fellow did not receive the message. That means police will be able to investigate based on that message. That means will they able to identify? Okay, you have sent this message to this fellow, something like that. Will they able to recognize that?
Okay, see, this is a cyber security question, but what the police will do, I'll tell. They will take last 2 to 3 days people who called him,
okay,
who messaged him.
Okay.
They will list out all the people and they have an inquiry with them.
Okay.
This is the normal investigation process they follow.
Okay. My question is only related to WhatsApp only. Okay. That means when we messaged in WhatsApp, single tick, I send a message to you. Okay. There is no double tick from my side. That means once in case if you switch on the like WhatsApp, maybe if you connected with the mobile net and internet, okay. So until that, okay, you're not supposed to receive that message, right? That means if I delete before that, okay. If I delete before that, will you be able to identify? That means you will get a message, something like that. Okay, like I have deleted the message, something like that.
This is which area?
It's I'm talking about WhatsApp.
No. But location.
Location Karnataka. Sorry, in Delhi it is happened. In Delhi it is happened.
Delhi it happened. Okay. See, it completely depends on the police who is investigating. Some people don't even care. They only focus on the last mobile call.
Okay.
What they have talked. 2 calls they will take and then they will send. Because if you have so many messages in the WhatsApp, they will not go through all the messages and follow them.
Okay.
The high priority will be in the phone call.
Okay.
Yeah.
Fine, sir. Fine. Thank you.
Thank you.
Sir, related to this, I want to ask one question, sir.
Yeah.
I think sir is asking whether the message will be delivered after deleting. He is sending the message. The receiver is not receiving the message. He is deleting. Before he is receiving it, he is deleting the message. After switching on the mobile phone, is it possible to store the cloud data will be send the data? He's asking that whether the message will be delivered to him.
Yeah, I will explain, sir, what happened here. See, when you send a message, now the message reached the cloud, WhatsApp cloud. Okay, now the message is, say, I told about cloud device management, right? Now the message is reached the IoT core. You can assume here, IoT core, the message reached it. Now it is asking the device manager, hey, this device is an online or not? And this guy is saying, hey, this device is not in online. Then it will put the message in the queue. Basically, it maintained the queue online. So it put it in the queue and there's a callback function, and it will tell device manager, hey, whenever the device is in online, okay, I have stored the message in this queue, you deliver the message to him. This is what communicated to the platform. Now the user, they haven't, so you are continuously checking, hey, the message is delivered or not, you're checking. It is in still single tick. Okay. Within 1 hour period, when you send a message, within 1 hour period, if you long press the message, it will show 3 options to you. One is delete the message for everyone, delete the message for me, delete the message for my friend. It will ask 3 options if you long press the message within 1 hour. Okay. If 1 hour is crossed, then the queuing, everything is done in the cloud already. So you can't. So it will only show 2 things. One is delete the message for me. That's it. It will only show 1 option, delete the message for me, because it's already delivered in the cloud. Now your friend, whenever he opens the phone, now exactly whatever use case he is telling, right? If he turn on the internet, the first message will be delivered is his message only. Might be some other route sent in the WhatsApp. All this message will be popped up in the notification. Okay, these are the people send messages, list of messages. It will pop up in the notification. Because 1 hour is our time to call back the message. When you pass that 1 hour, the message is already sent to the AWS core, AWS IoT core, and device manager, and then queue. It's already there. It is just waiting for the end user device to turn on, so it can push the message. So for this case, if the police taking and turn on the phone, internet is connected, the message will be delivered to him. It's a notification.
Okay. Thank you, sir. Thank you. Then you will be good.
Yeah, yes, sir. I hope this got the context. You understand how the entire messaging working.
Senthil sir.
Yes, sir.
Yes.
So recently you have developed one app, it seems. I have heard from Rajesh. Can you explain what exactly it is?
Okay, so during this Corona time, see, we get an opportunity to work with a lot of state government, like Tamil Nadu, especially Tamil Nadu. 12 district collectors, we started working with them. So one thing we identified see, in the initial stage, what they will do is the person who is come abroad to India, what this government used to say is they will go to their home and put a big sticker. Okay, these people are in quarantine, so neighbors don't come. But the thing is, they not even have a corona. They are corona negative, but they just come from abroad. So what government did is everyone home, the corporation put a big poster saying that please don't talk to these people for next 14 to 15 days. And they told they put huddles in front of their home, and they instructed the neighbor, don't allow these people come out of their home. So when the government nicely deployed everything, okay, the challenge is now these people need to go out to buy a milk. There is a baby, they have to buy a milk. They need to buy a basic accessories so that they can. So government nicely told, we will deliver everything in the home. Don't worry, there is a dedicated people in your area. Just you need to call them. That people come to you, they will give a milk packet, they will give a rice, they will give dal, everything they will deliver into their home. You don't worry. So this is what the government did in the March month. But when the cases are increasing, the number of quarantine people in a smaller town went from 10 quarantine people to 300 quarantine people within a week. When it was in a 300 people, the biggest challenge is you don't have any way to call, because the person who is attending a call, he's getting more than 100 calls in a day. I need a milk packet, I need a rice. He can't able to serve. So what the government did, not government, basically the people in the corporation, they don't even care. So people who are inside their home, they are not able to go because people are they can't go outside. Second problem is they could not able to. No one is delivering the food to them. So what these people thought, okay, fine. Now I have to take care of myself. So I will step out of my home. I will go to the shop and I start buying it. When the people come out, the neighbors are start shouting. Okay, they started treating them in a different way. So it created a huge mesh. So most of the collectors, they are interacting with us. They asked us, is there any technical way to solve the problem? So that is where we come up with this application called Quarantine Care. It's called Q Care. So what we have done is all these people, we gave this app. So everything they have requested in the app, and this app has a GPS. So we continuously monitor their GPS location. In a periodic interval, we ask them to take a photo. We tell the user, hey, you just need to take a photo and send it to us. So when the user take the photo, we capture the photo, recognize their face, and we understand that this user is in the home, only their homes. So we ensure the user is staying in the home, and all his necessary things like a food or a milk packet or whatever, he can request like in the same app that will be delivered. If it is not delivered within a 1 hour, that will be notified to the upper management. So this is a solution we built, and it really helped a lot of people. We monitor so many people using this technology. And later stage, what happened is many COVID is going very fast, like it's moving very fast. There are a lot of COVID positive patients, but they don't have a bed in the hospital because most of the government hospitals are filled, and they allowed private hospital to open up the corona care. The challenge is all the hospitals are filled, so they don't have enough bed. So now we come up with another innovative solution, which is the medical device. So what we have done is we provided this device to all the COVID positive patients, and we make them to stay in their home, and we attach the device on their wrist, and backside the doctor continuously monitor the patient. So for the 14 days period, their vitals, symptoms, everything will be captured in a real time and send it to the doctor. So when the patient is in the live call with the doctor, doctor can get what is his heartbeat. So all this experience in a real live call, he can get it from the medical device. So we monitor almost 4,000 people using this technology. This is application we built.
Oh, thank you, Shri.M.Senthil Kumar sir, for your social empowerment through technical competency.
Thank you so much.
Thank you, sir. So actually, we are privileged since you are spending a valuable time with us. So how to live, how to change ourselves in this on-demand changing world and economy and everything. Because nowadays, traveling from one place to other itself is highly complex procedures.
Yeah.
Not only now, recently we are having in England, no, they have adopted second lockdown because of this new wave.
Yes.
Actually, many were saying with the help of these supercomputers, we can within a month we can generate a vaccine like this. Many were saying because of that our
exactly.
Yeah, but it is in the context of the developed country, but we are in the developing nation contributing to the huge population of India. We need to have you like social empowerment personalities to achieve developed position.
And we also need professor like everyone like you people to join with us to build solution. We are ready to commercialize
sure.
this. Of course, we need your support on this.
Yeah, sure, sir. Actually, we are like education institutions. We'll support you for your social empowerment.
Thank you so much.
Thanks a lot, sir, spending a valuable time with us.
Thank you so much.
Yeah, your session was very informative, sir. Actually, we learned a lot socially apart from technical. We learned a lot of things. But actually, we can say is now we are seeing a new world. That's a real. So that's a real scenario now. It is not like before March. Actually, we are seeing a virtual world now.
Yes.
So that's the real one. Everything is like virtual reality. We are speaking to someone, but we don't know what we are intended to speak to that particular person. It's all because of that.
Yeah. True.
Yeah. Maybe it will all once it will get systematically, once maybe in 5 to 6 years, we'll be having robo near to us in the near future. because yes, I think we together social empowerment agencies along with educational institutions promote digital India to have a super developing economy.
Sure.
Yeah, sure, sir. Thank you, sir. Thank you.
Thank you, ma'am. Thanks for this opportunity, and feel free to share my email ID. And anyone has any query, feel free to send a mail. I'm happy to support it.
Yeah, sir. Can you please kindly mail your PPT to that mail ID I have mentioned now?
Yes, ma'am. I will do that after the session. I'll send her.
Yeah, sure, sir. Thank you, sir.
Thank you, ma'am. Thanks a lot.
Participants, we have uploaded that attendance link 15 minutes before. You just fill it and then you can leave the session. Okay, it is in the chat box now. When you're coming to next session, it won't be appear. Okay, so please fill it now and then you can leave the session. Our next session will be on IoT insemination and deployment by Dr. S. Tayamal ma'am. Kindly join the session 10 minutes before the starting. Okay. Thank you, everyone. You can fill your attendance link and then you can leave the session because this attendance link won't be appeared when you're coming for the next session. 80% attendance is mandatory for earning an attendance certificate. Okay. Thank you.